Hi, my name is Anthony Harrell, a senior at the University of North Carolina, Charlotte, with a degree in computer science or major in computer science and a concentration in cybersecurity. And today I will be talking about Go Back In, which is simply a procedure paired with pipelining that allows multiple frames to be in flight at the same time. Now, this is the opposite of stop and wait, in which only one frame could be transmitted at a time. You have to wait for the first frame to arrive to send the second, and then wait for the second to arrive to send the third. Now, of course, with this kind of technique, both stop and wait and pipelining itself, there will be problems. So, what is the problem with stop and wait? The problem with stop and wait is the fact that it's not very efficient. You have to wait for the frame to arrive in the next every single time. In that sense, you'll be spending more time waiting than actually using the network to its full potential. And the problem with pipelining itself is, what do we do with frames after a failed frame? For example, this illustration shows the first frame being sent and the second frame being sent. If this fails to arrive at the destination from the source, but this arrives, what does the destination do? Pipelining just in itself, by the concept, doesn't specify this. So that's why we need Go Back In. It allows for greater efficiency, and it illustrates what to do after a frame is dropped. So Go Back In allows a sender to send up to W frames without an acknowledgement. The data link layer will only accept the next frame in the sequence. So if one frame is dropped, it will not accept the other if it hasn't received the other. As stated here, the frames in the sequence are dropped and they are retransmitted. That is the most crucial part of Go Back In. Unless you have ultimate advantage, of course. So how does Go Back In works? I will illustrate it here. So we have our source and we have our destination. So let's say I send my frame 1, my frame 2, and my frame 3. Let's say 1 arrives perfectly fine, 2 doesn't arrive, but 3 arrives. The destination realizes it hasn't received 2, so it doesn't acknowledge the third. So this acknowledgement will come back for 1, but it won't come back for 2. So that's when the sender will realize, okay, I must retransmit 2. And once it retransmits 2, it has to, according to Go Back In, it will retransmit the third as well. And this acknowledgement will come back, hopefully, for the second frame, and the acknowledgement will come back for the third frame. And everybody's happy. And it's question time, true or false. If the sender has a resend frame 3, let's call this frame 3, it will also have to resend frame 4 and 5. That's frame 4, and this is frame 5. So this gets lost. The acknowledgement never comes back, even though the destination receives 4 and 5. And this is assuming there is no ultimate acknowledgments, cumulative acknowledgments. And with this statement, it is true. If it has to resend 3, it will resend 4, and it will resend 5. Thank you.